Team2, and this is our Week 8 project about the Hyundai Seoul. We gave a foundation construction method of the Hyundai Seoul last week. In this week, we are going to give you a foundation construction method of the Hyundai Seoul. Our topic for this week is Hyundai Seoul's base structure and core. The Hyundai Seoul's framework is largely divided into two sections: the reinforced concrete structure for underground and the steel structure above ground. First, let's look at the RC structure underground. The 7th to the 2nd basement floor is a flat slab structure using reinforced concrete because of its economic feasibility. The structure consists of 8.4 square grid unit with beams and columns, and the concrete was laid out in system form method and Euroform method. System formwork refers to a form that integrates, unitize, enlarge the formwork in advance and the support that reinforce it. There are many advantages in construction management, such as securing the precision of the frame construction and shortening the construction period through the construction simplification. In particular, gang foam formwork and RCS formwork were used in the basement construction of the Hyundai Seoul. Gang foam refers to a large formwork made by integrating an outer wall mold and a scaffold cage in a cross-sectional structure with the same upper and lower parts on a plane, such as high-rise apartments. An RCS is working scaffold for wall formwork and is an integrated rail system that integrates the working scaffold for the formwork installation, scaffolding frame, and finishing scaffolding after placing concrete. Euroformwork system is standard form in Europe, and it is the form most commonly seen in the domestic field. Usually 600 by 1200 mm is the basic dimension, and there are several types by size. The spacing of the steel frame inside the form is 300 mm, and the wedge pinhole for assembling or bonding between the form is drilled every 150 mm. This RC structure has high-strength rebars, and an economic evaluation was conducted to select the appropriate rebars. This resulted in the use of high-strength rebars of SD500 above D13 and SD600 above D16. In addition, concrete combination tests were conducted directly at the construction site, and the proper specifications were selected for its environmental condition. As the construction of the basement floor, the core wall were built at the same time. A total of 11 cores were constructed one floor earlier than the slab layer by using gang foam method. Next, let's look at the structure on the ground. The ground floor of the Hyundai Seoul consists of 8 cores and steel frame, and a large steel structure is installed on the roof to realize an indoor space of 50 by 50 meters. The first basement floor and the ground structure were constructed with steel structures. 2 tower cranes and 3 temporary lifts were used during the construction of the ground and remained to transport the material until the 3rd floor structure were completed. In general construction, raw H-beam is commonly used for steel structures, but in this project, a special steel frame called post-BH, developed by the constructor POSCO ENC, was used. Unlike conventional standard RH beam, this post-BH can be customized for its construction field, so it can reduce costs since the constructor can use the exact size they need. In particular, the beams were designed as hybrid beam through collaboration with the KSSC. The flange part of the beam member was designed with high-strength TMCP, and the web part was designed with General Steel. On the other hand, various methods of bolting and welding were used for joining steel frames. For general members, bolting was used to shorten the construction period, and welding was used for large members that could ignore construction errors. Especially for welding, the angle of PJP was 6 degrees before the suspension of the construction, but it was changed to 45 degrees through WPS, saving welding time and cost. As we can see, the structural methods of the two sections are different, so the transfer girder was required to transmit the load on the top to the lower structure. The thickness of the transfer girder is very thick, 1 to 2 meters, so there were some cases to divide pouring section. For example, when the amount of ready-mixed concrete is insufficient, or the load is required to be divided. In order to connect two success pours, shear connector should be added. In the construction, a number of small rebars of D10 and D13 were installed to ensure structural stability. We will cover more details at another time. The load of a large steel structure on roof is transferred to the crane and is designed to transfer from the crane to the podium and from the podium to the retail core wall. At this time, a shear structural truss and cable were used to support the tensile force of a large structure, and the load was designed to be symmetric while matching the direction so that the load was transmitted effectively to the core. In addition, the tie connected to the retail core on the crane increased the rigidity to reduce the sagging of end arm on which the kite is hung, and also reduce the vertical movement in response to horizontal load. Most of the underground structure of the Hyundai Seoul was originally completed by Samsung C&T, a constructor before suspension, but the design was changed as the constructor was changed. Main reason was that Hyundai department store participated in this project. According to the original design plan, the retail section of Park 1 was designed as a shopping mall, not a department store. Unlike the general design of department store, there was a large void on the first floor that was connected to the basement, and the column gap was narrow, so retail store was open in between. However, as construction resumed and department store came in, the design was changed, filling the first floor void and adding beams to the second basement floor to reinforce the load. This is because when the food hall enters the first basement floor, it needs to be separate from other floors due to hygiene problems, and when kitchen facilities were installed, the load increased, so stability was not secured by existing design. In the next week, we will talk about the steel structure of the ground floor, the biggest feature of this building. Thank you for listening.